Hey guys, welcome back to geometry. Last time we were together, we were talking about the angle relationships that exist when you have parallel lines intersected by a transversal. We have alternate interior angles, alternate exterior angles, and corresponding angles are all congruent, and then consecutive interior angles are supplementary. And we were using these relationships to determine which pairs of angles were, excuse me, which pairs of lines were parallel. Okay, because it works in both directions. Not only if we know the lines are parallel do we know these angle relationships, but if we know these angle relationships, then we also know that the lines are going to be parallel. So we've used that to find some pairs of parallel lines. What I want to look at now is going the other direction, okay, or doing the other option, I suppose. If we have certain angle pairs are congruent or supplementary, which lines can we say are congruent? Okay, well, first off, we're going to have to add a little something here. This diagram is missing some labels. Let's call this line L, let's call this line M, and let's call this one J. That's going to be important for us later on. Okay, now, they tell us that angle 1, excuse me, angle 4 and 5 are congruent. Okay, and they want us to prove that lines L and M are parallel. Well, we know that with any proof, we have to start with the given information. So we'll start with saying that angle 4 is congruent to angle 5. Okay, and that's a given. Now, okay, so on these ones, we want to look at this for the other option. Okay, we want to try to take the fact that we have a pair of congruent or supplementary angles and use that to determine or to prove that some lines are parallel. So we have this diagram here with lines L, M, and J and angles 1, 2, 3, 4, 5, 6, 7, 8. They tell us that angle 4 and 5 are going to be congruent, and they want us to prove that lines L and M are parallel. Okay. Now, the easy solution here to look at this is to say that angles 4 and 5 are alternate interior angles. And if alternate interior angles are congruent, that means that lines are parallel. However, we can see that they have a few more steps here, and none of them deal with alternate interior angles. So we're going to have to take a slightly different approach. Okay, but we do know this. We do know that we always have to start with the given information. So we're going to start with angle 4 is congruent to angle 5. Okay, we have to start there. Okay, the next thing that they want to say, they want to talk about are vertical angles. Okay, well, vertical angles are going to be congruent. There's a lot of pairs of vertical angles here. I could say that angle 7 is congruent to angle 6. I could say that angle 1 and 4 are congruent. There's a lot of different options that we could use. So I need to think about what's coming next. Okay, there's going to be some substitution, and there's going to be something involving corresponding angles. So if I take a look at this, guys, these angles that I listed up here, okay, 7 and 6, these aren't corresponding to anything. That's not going to be very helpful. But guess what? What if I take a look at angle 8 and angle 5? Those two are vertical angles. And then angle 8 and angle 4 are corresponding angles. So this seems like a good approach that we could use. So let's try this. Let's say angle 5 is congruent to angle 8 because vertical angles are congruent. And that's true no matter what. Whether we have parallel lines or no, those lines are going to be congruent. Excuse me, those angles are going to be congruent. Now, we're going to take this angle 8 and we're going to sub it in place of this angle 5. Okay, we'll say angle 4 is congruent to angle 8. Okay, and we say substitution property, or we could say that this is the transitive property. Okay, and in fact, the transitive property would be more accurate. Okay, but regardless, now we have angle 4 is congruent to angle 8. Now take a look at angles 4 and 8. Angles 4 and 8 are corresponding angles. And if corresponding angles are congruent, then we can say that those lines are parallel. Lines L and M are parallel. Okay, and that's what we set out to prove, and we proved it. Okay, so if we have certain angle pairs congruent or supplementary, we can use those to say that these lines are going to be parallel. And we can use those as reasons along our proof. Okay, so this one gets a little bit more complex. We're given the lines R and S are parallel. Okay, so that's these ones. So here's line R, and here's line S, and we have that those two are parallel. They give us that angle 5 is congruent to angle 6. And, they want us to prove that lines L and M are going to be parallel. That's our objective, those two right there. Okay? And they give us some steps along the way. Well, we know where we're always going to have to begin is with our given. So start by saying that line R is parallel to line S, and angle 5 is congruent to angle 6. Okay, we know that's true because that's the given information. Okay, now next up, they tell us that angle 4 and 5 are supplementary. Okay, now how would I know that angles 4 and 5 are supplementary? Well, take a look at where they are. Okay, angles 4 and 5 are both along this transversal L, okay, and they're formed along these two lines here, R and S, okay? And if R and S are parallel, 5 and 4 are consecutive interior angles. Consecutive interior angles on parallel lines are congruent. So that's actually our reason. Consecutive interior angles on parallel lines are congruent, or are supplementary. Okay, then the next reason that they give us is the definition of supplementary angles. So we need to think about what that actually means. Well, what does it mean for two angles to be supplementary? It means they add up to 180 degrees. Well, that's what we can say then. We could say that the measure of angle 5 plus the measure of angle 4 equals 180 degrees. Okay, and then kind of out of nowhere, they come in with angle 5 and angle 6, the measures of those two angles being equal. Okay, well here's the deal, guys. It's not actually out of nowhere. This statement comes from this statement. Okay, so what we have is the definition of congruent angles. Okay, if they're congruent, that means that their measures are going to be equal. All right, then substitution property. Well, substitution property says that we can replace stuff. Okay, well, I have this equation here, and I have that angle 5 and angle 6 are congruent. Their measures are equal. So I'm going to put the measure of angle 6 in place of the measure of angle 5. So instead of measure of angle 5 plus measure of angle 4 equals 180 degrees, we'll say the measure of angle 6 plus the measure of angle 4 is 180 degrees. And then the next statement is we're saying that angles 4 and 6 are supplementary. Well, guys, once again, that's the definition of supplementary angles. Okay, now we have one more step. Okay, and this one's described for us, or all set up for us, so we know we have to end on lines L and M being parallel. So we'll say line L parallel to line M. But we need a reason. Okay, well, if 4 and 6 are supplementary, take a look at where 4 and 6 are on our diagram. Okay, here's angle 4, here's angle 6. They're along this transversal, and they're formed by these two lines. Okay, lines L and M. Angles 4 and 6 are consecutive interior angles. Okay, so that's our reason. If consecutive interior angles are congruent, or supplementary, keep doing that. If consecutive interior angles are congruent, or one more time, then lines are parallel. Okay, and there we go. Okay, so we take a look at what angle pairs we have. Okay, we find the relationships that exist between them, and we use that to prove lines are parallel. Okay, let's take a look at one more, and let's look at this one from start to finish. Here we have the exact same diagram, but some slightly different information. Okay, they give us the angle 1 and 5 are congruent, and angle 15 and 5 are congruent. Okay, and what they want us to prove is that both pairs of these lines are parallel. They want us to prove that lines R and S are parallel, and lines L and M are parallel. Okay, well, what we can do right away, we know we're going to have to do, is start with our given information. Okay, so we can start by saying that angle 1 is congruent to angle 5, and angle 15 is congruent to angle 5. Geez, having a little trouble with that equal sign there. There we go. And the reason that we know that's true is because it's given. All right, now, there is a shortcut that we can use on this one. However, I want to show us how we can use some more properties to get this job done. So we're going to focus on just corresponding angles for right now. Okay, we'll get the other ones in later on. Right now I want to focus on just corresponding angles. So I have one pair of corresponding angles right away. Okay, I have angles 1 and 5. Okay, however, so I can say right away that angles 1, since angles 1 and 5 are congruent, I can say that lines L and M are parallel, okay? Because they are corresponding, excuse me, not L and M. Yeah, lines L and M are parallel because if corresponding angles are congruent, then lines are parallel. Okay, and fix this up and change that equal sign into a congruent symbol. So if corresponding angles are congruent, then lines are parallel. All right, next up. Okay, I want to find some more stuff with corresponding angles. So I've already gotten lines L and M parallel. Okay, now my next objective is to get lines R and S parallel. Okay, so that means I'm going to have to work with angles 5 and 15. Now, once again, there's a shortcut here. We could say that because angles 5 and 15 are alternate exterior angles, that makes those two lines parallel. Okay, however, I want to stick with just corresponding right now. So what I need to do is get an angle that's corresponding to one of these two, okay, congruent. So let's look at angle 5. What angle over here would be corresponding to angle 5? Well, angle 13 would be corresponding to angle 5. So I want to say somehow I need to get angle 13 into the mix. Okay, well, what would angle 13 fit with? It fits with angle 15. How do I know that angle 13 and 15 are congruent? They're vertical angles. And vertical angles, whether you're dealing with parallel lines or no, are always congruent. Okay, guaranteed every single time if you have vertical angles, they are going to be congruent. Well, now I can use that transitive property to say that angle 5 is congruent to angle 13. And if angle 5 and angle 13, okay, take this original statement to this one to here. The reason that works is because of the transitive property. Okay, both angles 3 or 5 and 13 are both congruent to angle 15. So we cut out that middleman and we say they're congruent to each other by the transitive property. Okay, now I have angle 5 and 13 congruent. Those two are corresponding angles again, which means the lines that they're on, okay, so here's the transversal that forms angles 5 and 13, and here are the other two lines involved. That means that those other two lines are going to be parallel. So those other two lines are lines R and S, and we can say that they're parallel because if corresponding angles are congruent, then lines are parallel. Don't forget to make that congruence or that equal sign into a congruent symbol. And there we go. Okay, we've proved that L is congruent or parallel to M, and that line R is parallel to line S. To prove what we set out to prove, we are finished. Okay, now on these proofs, we really focused on just the corresponding angles aspect, but using that, we've proven that alternate exterior angles congruent means the lines are parallel, and the other ones as well. Okay, so we can use any of those reasons to show that these lines are parallel. So when you're given congruent angles or supplementary angles, What you want to focus on is what relationship exists between those pairs of angles, okay? And what lines are they on? Then can we say that those lines are parallel?